We're given vector A and B in component form and asked to find the projection of vector A onto vector B. So there are several ways to visualize this. If we project vector A onto vector B, we're trying to determine how much of vector A is in the direction of vector B. But we can also think of shining a light directly on vector B from above, somewhere up here. The shadow of vector A on vector B would be the projection of vector A onto vector B. It's helpful to sketch a right triangle using vector A and B to sketch the projection. If we drop a perpendicular from here, this leg of the right triangle would be the projection of vector A onto vector B. And we use the notation, the projection of vector A onto vector B, which should be equal to, using this formula here, vector A dotted with vector B divided by the magnitude of vector B squared times vector B. And we can derive this formula by determining the magnitude of the projection and multiplying by the direction of, in our case, vector B. So this would be equal to vector A dotted with vector B, which would be 3 times 6 plus 5 times 2. So again, we'd have 3 times 6 plus 5 times 2. We'll divide this by the magnitude of vector B squared. Well, the magnitude of vector B would be equal to 6 squared plus 2 squared, or 36 plus 4, and this is squared. Then we multiply this by vector B. So looking at our numerator here, we have 18 plus 10, that's 28. The denominator would be the square root of 40 squared, which would just be 40, and then times vector B, which has an x component of 6 and a y component of 2. Simplifying our fraction, there's a common factor of 4 here. That would be 7/10 times vector B. Performing the scalar multiplication, we would have an x component of 42/10, comma 14/10. But of course, these fractions simplify. 42/10 simplifies to 21/5, and 14/10 simplifies to 7/5. So this would be the projection of vector A onto vector B. Notice if we called this projection vector W sub 1, and we called this vector here vector W sub 2, notice that vector W sub 1, our projection of A onto B, plus vector W sub 2 would equal vector A. But again, for this question, we were asked to find the projection of vector A onto vector B, which is this vector here. And here's another graph of the projection of A onto B, this green vector here. I hope you found this helpful.